Alright kids, here's what I was supposed to finish last night, but technology. I'll try to make this as quick as possible. So this is 2.3. So these are the last notes that we should have finished, 5, 13, 20. So this increasing and decreasing stuff is super important in calculus. I just want to introduce it to you, make sure you can read it on graphs. You'll talk about it more in calc. Alright, so definition, a function is said to be increasing on the interval x1 comma y1 wherever x1 is less than x2. So this input is less than that input, so like 2 and 3. Okay. We will have the first output, is less than the second output. So understand this notation. These are input notations. Look at this. This is input, and this is output notation. So it's increasing if your first input is smaller than your second input, then that means your first output will be smaller than your second output. The graph goes up as you move from left to right. Okay. You always read graphs from left to right for everything. So if we look at this graph from the interval, the interval from x1 to x2, the graph is moving up from left to right. Okay, so your first output is smaller than your second output. So at this interval, the graph is increasing. Okay. So another way to write this, I don't remember how the book writes it. It may be closed brackets, so we'll see how your homework takes it. When they ask about increasing and decreasing, either soft brackets or closed brackets, you can do either one. We'll see what the book is accepting on your online homework. Okay, so on that interval, you list the x values in which your outputs are increasing or decreasing. Okay, so x values, your inputs, at which your outputs are increasing. Okay, all right. Oh, I'll skip that. So now for decreasing, a function is decreasing on the interval x1 comma y1 or x1 comma x2. Okay. Whenever x1 is, so your first input is smaller than your second input, you will have your first output bigger than your second output. So the graph goes down as you move from left to right. So again, still the same thing on this interval from the first to the second x. This time, as you move from left to right, your graph is decreasing, it's going down. So your first output is larger than your second output. That's what this guy is saying right here. Okay. So your graph is decreasing. So again, you can also write it as x1 comma x2. Either notation should be good. Okay, so you want to be able to read graphs from left to right and see if those pieces of the graphs are increasing or decreasing. So let's do an example. Alright, so on what interval or intervals, so you can have more than one interval in which your graph is increasing or decreasing, is the function increasing. So part A I did in red. So reading from left to right, I'm going to start from left and right. So the graph, if we start from the left, the most left side of the graph, and read from left to right, this piece of the graph is increasing. From left to right, it's going up. So what x's are those? So those guys, okay, so this graph goes on forever, right? And ever and ever and ever, whether it has arrows or not. Okay. So those x values are actually negative infinity. So all of those x values, because your graph's going to be increasing. To, what is this x value? 3. Negative 3, sorry. And again, brackets, no brackets, it's up to you. I'll just use soft brackets. Okay. Also a piece of the graph, so then you would say union. Right here, the graph, the x value, where the graph starts to increase again, is 1. And then goes all the way to, again, to infinity. So these x values, okay, to infinity. So those are the intervals at which the graph is increasing. Okay, as you read from left to right, the graph is going up. Now decreasing. Okay, so if you look at this graph, this blue part that I shaded, as we read from left to right, the graph is going down. Okay, so that starts at negative 3, and it goes to x is equal to 1. Okay. I had a big old conversation started with people in the math department about brackets, soft brackets, hard brackets, why. I asked why. I had people like debating over it, like this big old nerdy discussion. To me, I think it should be soft, but it can go either way. Okay, but just whatever you do, be consistent. Either all soft brackets or all hard brackets. Besides the infinities, you know those are always soft. Okay, so there's your increasing and decreasing, how to read a graph from left to right. Remember, it's the x values in which your graph is going up or your graph is going down. Okay. All right, let's do some more examples. This is all review from 1050, but I just want to make sure we remember it. It's going to be on your homework quiz, could be popped up in the final, so just being able to read graphs. So a definition, an asymptote is a line which the graph of a function approaches but never crosses. That's not always true. Okay, sometimes it does cross. You'll see, especially in calc, when you truly understand asymptotes. Okay, that's all about limits. Anyways, it is usually denoted by a dashed line. Okay? All right, a hole in the graph is a place where the function is not defined. That is true, and there is no output for that particular input. Okay, hole, i.e., open circle. Alright, so we're just going to do some examples and keep it moving. Alright, so state the domain and the range. Again, this is review from 1050. So domain is all the x values that have graph above or below it. So reading from left to right, your graph starts at x equals negative 1, 2, 3, 4. And it's included because this is a closed circle. So above negative 4 is where your graph starts. X is negative 4. Then it stops at x is negative 2. Open circle, because there's no solid graph above or below negative 2. Union. Starts back up at negative 1, but it's open circle. There's no solid graph above or below negative 1. And it goes to 2. Now let's look at 2. At x equals 2, there's no solid point there, but there is a solid point there. And then after 2, it keeps going. So 2.1, there's graph here. 2.2, there's graph here. 2.3, etc. 3. So you actually don't have to stop at x equals 2, because when x is 2, you get that point. When x is 2.1, you get that point. So it keeps going. So x is equal to 1, 2, 3, 4. So that's where you would stop at 4, and it's included because that's solid. Okay. So some people want to stop at this part right here, but you don't have to, because again, at x equals 2, there's a graph. At x, just after x equals 2, like 2.00001, there's graph down here. So you don't have to stop. So here there was a gap. There was no points in that space, so we had to jump. Okay, there's the difference. Alright, your range, those are your y values. So you're going again from smallest to largest, so bottom to top. So where does your lowest y value start? So that is y equals 1, 2, 3, 4, 5, 5. Negative 5, and that's solid. So included. Up to y is negative 1, and that's open. There's no graph at the negative 1 level. Okay. So negative 1, soft bracket, union. It picks back up at, the graph starts back at y is 0. This right here is y is 0, but it's not included because that circle's open. So 0. And then y is 0.1, you got graph. 0.2, you got graph. 0.3, 0.4, 0.5. Y is 1, that's open, but that's closed. You only need one spot to be included. Y is 1.2, 1.5. Look at y is 2. You got that point and that point, so you're safe. You only need one. So you go up to y is 1, 2, 3, 4. So your graph stops at 4, and it's closed. Okay. All right, now f of x equals 2. Okay. This means y equals 2, so find x. Okay. So go to the y level of 2. We just talked about that. 1, 1, 2. When y equals 2, you got two numbers. Okay, so two x values. So this is the y level, y equals 2. And the x values are here. So that's 2. And the x value is negative 3. So x equals negative 3 or x equals 2. So you can have more than one solution for those guys. Notice it says find all inputs. So it's possible to have more than one solution. More than one answer for those guys. Alright. Let's do the next one. Domain. Okay. Again, we're reading from left to right. We're reading our x values where there's graph. So the graph starts at -4, and this dot tells us it stops. It doesn't go on forever. Okay, so it starts at -4. It doesn't go past that. It's included. It's solid. It stops at -2. There's no graph above x equals -2, and it's open, union. It doesn't start back to -1, and it's open because of this circle. We don't have any solid graph above or below -1. And then all this graph, and then y is 5 is where it stops, and it's open because of that open circle. Alright, now your range. So your lowest y value is -3. It's not included because the open circle, and there's no other graph at the y equals -3 level. So you go up, there's graph, and y is -2, there's graph, y is -1, there's a bunch of graphs, so there's all that. Y is -0.5, we're good. Y is 0, we're good. Y is 1, we're good. All the way to y is 4, and then there's no more graph above 4. So our graph goes to y is 4, but it's not included because of that open circle. Alright, and then it says find f of 0. So that is when you plug in x equals 0, find y. Okay, so know the differences between those two guys. So x equals 0 is here. Where's y? Right there. So -1 is your y. And be careful with these ones, only one solution. Or it's not a function anymore. Only one solution. Otherwise it's not a function. So you can't have, when you plug in 0, you can't have -1 and have like a point here, -3. Nope, it's no longer a function. So only one output. Here you can have multiple inputs. Okay, so that's the difference. Alright, I did this last one, okay, but try that on your own and then go check it with my work. Okay, I did the last one for you guys. Alright, so now let's kind of bring all this crap together with this crazy graph I have. And do increasing, decreasing, domain range, all that good stuff. Alright, domain. Okay, so I got asymptotes here, open circles, closed circles. I got all kinds of stuff here. So this is the craziest graph you could possibly have. Oh, that could be crazier. Alright, domain. So from left to right, the x's. So this little arrow goes on forever. Okay. So -infinity. And you go to the graph and you're going along the x-axis looking for graphs so far where it's nice and solid, so we're good. And then you get to x is -4, and on that asymptote there's the graph doesn't cross it, there's no solid point, so you got to stop at -4 and say not included, union. The graph picks up at -4 because this graph gets as close to -4 as possible, so you have to start at -4, not included, and then everybody after, or whoever after. And then you get to y, or x equals 0. This is an open circle. Is that closed there? Yeah, that's closed. It's just a little hard to tell. So that is continuous. So you go to x is -4, x is 0. That's closed. So we don't have to stop. Okay. I know it's kind of hard to tell, but it's there. You gotta show somewhere. Okay. And then you get to 3. And look at, there's a point on this asymptote. Something weird happened, then that's possible that it happens, okay? So we're not stopping yet. So far, from x is -4 to x is 3, we have a graph everywhere. Okay, graph there, graph here, graph there. And just after 3, this graph down here covers it. So 3.01, we got graph down here. 3.00001, we got graph down here. So we're not stopping yet. And then you go to x is 8, and we have to stop. Open circle. There's no solid graph above or below 8. Picks back up at 9, but it's an open circle, or cool, or solid. You get to 11, you gotta stop. Open circle. Then you get to 13, and there's graph, but it's all by itself. So this is how you show something's all by itself, but it is included. Sorry, my graph's kind of dingy. So that was that crazy domain. Don't worry, they won't be that crazy on a test or a quiz. Alright, now my range. So from -infinity, okay, our graph goes from -infinity, remember that goes on forever and ever. Okay, so as long as there's no solid point or open circle stopping it, it goes on forever. So negative infinity. That's infinity symbol, I promise. And we're climbing up this, and we're just looking for graph left or right. Okay, if it's both, cool. Look at, there's graph there, graph there. Get to here, it's open, but there's closed and there's closed, so we're set fine. Graph there, there, and there. Okay, look at this guy. There's a graph here, 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 here. Okay, the asymptotes don't count unless there's a point on them. So if you look, this graph's going to cover it all the way to infinity, and that part's going to cover all the way to infinity. So you are all the way to infinity with the range. This guy right here covers the whole y-axis. Okay. So there's the range. Okay. And then increasing. What interval or intervals is this graph increasing? So from left to right, here we go. So from left to right, this guy is increasing. Okay. So negative infinity. So x is negative infinity to x is negative 4. And I'm going to use soft brackets. From negative 4, that's decreasing, but this piece right here is increasing, so union. Okay. Negative, or that's 0, x is 0, to x is 3. Okay, so increasing, union. And then right here, so it's like at what point does it start to increase? About right there. So we'll say like 3.4. This is kind of janky graph to do this, but it's fine. To x is 8. Soft bracket. Okay. And here, is it increasing or decreasing? It's neither. It's staying flat. Okay, this is all calculus, so don't freak out. Okay. Oh, you know what? I just thought about something. Technically, these asymptotes and increasing and decreasing, something weird happens, so I shouldn't even be doing increasing and decreasing on here. But it's fine. We're just for basic understanding, no big deal. We're not going to think too deep because it's not calculus. Alright, so decreasing. Oh, you know what? This is increasing all the way here. That is all increasing. So again, asymptotes are weird, so this is kind of a janky example. So we're going to say 3. From 3 to 8, it's increasing. Okay, so the janky example, my bad, no big deal, don't freak out. You'll really study it in calc. I'm gonna wipe that out when I get the chance. That's nasty. Alright, and then now decreasing again. This asymptote stuff is barely, it's not a good example, but left to right. So we got negative 4 to 0. That's it, because that's flat. Okay, so this is neither increasing nor decreasing. Increasing or decreasing, right? You get the point. Okay. So don't think too much about increasing, decreasing. It's more of calculus, and then asymptotes are special, so just, you'll survive. Alright. And then the last thing was this example. I told you to look at it, okay, and if you want me to do a video, email me, tell me, I'll do a video for you and how it all goes down. But I just want to end this video here. I'll upload all these notes so you're cool for 2.3. Okay?